Sig Test 7, we're multiplying these binomials together. I make a generic rectangle, length, and the width, and then you just find the area of each little rectangle here. So 2x times x is 2x squared, x times 3 is 3x, 2x times negative 2 is negative 4x, and negative 2 times 3 is negative 6. So you just find the area of each one, combine the like terms. These two are alike. That's how I got the negative x. And then the 6 and the 2x squared. Same thing for each one of them. 3x minus 5 is 3x minus 5 times 3x minus 5. Find the area of each one, combine like terms. 2 by 3, so you have a binomial and a trinomial. So my box is going to be 2 by 3. Just find the area of each little box. 2x times negative 2x is the negative 4x squared. Then you combine like terms. Add those together, you get negative x squared. Combine those together, you get 0, so it's gone. And there's the 9, there's the 2x cubed. Solve the equation. Distribute. So that's how you get the 5x, negative 10, and the 4. Distribute. So that's 3 times the x, 3 times the 4. Combine like terms, combine like terms, combine like terms. I like to get all my x's on one side first, so I subtract 5x from both sides. Add 6 to both sides, and that's how I got 0 equals 6x. Divide by 6, and you get 0. This one's no solution, because after you distribute and combine like terms, you end up with negative 6x and negative 6x on this side, and when you add 6x, they both disappear, and you're left with something that's not true, so it's not equal. No solution. Hey, look, the bases are the same. If the bases are the same, then the exponents must be the same. So I just put the exponents equal to each other and solve. The bases are not the same, so I'm going to make them the same. 9 is just 3 squared, and the x is still there. 27 is just 3 cubed, and the x minus 7 is still there. So the bases are the same, the exponents must be the same. Put them equal to each other and solve. This equation has a fraction in it, so I like to multiply by the common denominator to get rid of those fractions. It's just 15 times 4 divided by 5 is 12. 15 times x divided by 3 is 5x. 15 times 2 divided by 5 is 6. And then you solve it like a regular equation. And I have 6 times x divided by 2, 6 times 3 divided by 2, 6 times 2 divided by 3, and 6 times 5x divided by 6 is 5x. Combine like terms, get all my x's on one side, and finish solving it. Flip it over. I'll explain the meaning of the slope. Well, in this problem, you have these refrigerators, and they are selling 4 refrigerators per week, because their slope is negative 4, so it's going down 4 every week. And the y-intercept's 300. That means you start off with 300 refrigerators. On week 30, you would plug in 30 into the equation, and when you plug that in, you end up with 180. So, but they really had 160. So they had 160, you predicted 180, so that's a residual of negative 20. Given the sequence, it looks like we're adding 3 every time. So this is the first term, second term, third term, fourth term. So I need the 0 term to write the equation. So I just went back 3. And that's how I know it's 3n plus the 2, because it's changing by 3 each time. And it started off with 2. 50th term means just plug in 50. 150 plus 2. Can 80 be part of the sequence? Well, if I plug it in and I solve and I get a whole number, then yeah, it's a term of the sequence. And that's the phone. Here the sequence is going down by, a different amount each time. So it's multiplying by a half each time. Times a half, times a half. And that's why it's 1/2. And then going backwards, I would multiply by 2 to get the 160, and that's what I start with, because this is a first term, second term, third term. That would be the 0 term. I have multiplying by 3 every time, by 3, by 3, and divide by 3, and I get the 0 term. So that's where the 2 comes from, and the 3 is what we're multiplying a whole bunch of times.